So question 4, this is about a resistance calculation question. So if we have a look at the question, the picture shows an electric cooker, hob. The simplified circuit diagram shows how the heating elements connect to the main electricity supply, and the heating elements are identical. When all 4 heating elements are switched on at full power, the hob draws 26.4 from the 230 mains supply. Calculate the resistance of 1 when it's switched to full power. So the first thing we need to do here is we need to think about this 26 amps and how it's going to get split between that. If they're all on, it's 26 amps. So to get that, the value for 1, it's going to be 26 amps divided by 4. That's going to give us 6.5 amps for the draw on 1. We're then going to use the equation R is equal to VI, okay, where the resistance is equal to the potential difference divided by the current. The potential difference is 230 divided by 6.5, which is going to give us a resistance of 8.8 ohms. Okay. All right, we're looking at a data question now. And the data question here is the table gives the maximum current that can safely pass through copper wires of different cross-sectional areas. So we can see as the cross-sectional area increases, the maximum safe amount of amps increases. The power sockets in the home are wired to the main supply using cables containing 2.5 millimeters squared copper wires. Most electrical appliances are connected to the mains electrical supply by plugging them in a standard socket. This would not be safe to connect the electrical cooker hob to the main supply by plugging it into a standard socket. So we need to look back at the information we're given in this answer, and we can see here that it potentially can draw a maximum of 26 amps. So we're going to take that 26 amps back to our question. 26 amps here. That is more than that cable can do. Okay, so what would be the implications if we plugged that in? Well, it exceeds the current or the maximum current of 20 amps by 6 amps, we could say. And then if we think about that, what would happen then? If we've got too much current flowing, that's going to cause the wire to heat up. And if the wire heats up, it's going to overheat the wire and melt the plastic. Perhaps could cause an electrical fire. So overheat the 2.5 millimeter squared wire, which could cause an electrical fire. Okay, last question here. Mains electricity is an alternating current supply, battery supply direct current. So what is the difference between AC and DC? So AC is constantly changing direction. DC flows in one direction only. Okay, make sure you got all your answers down. Thanks very much.